Unit 10, Lesson 5, Evaluating Trig Functions. We're going to be evaluating trig functions and ratios on the coordinate plane. So our goal, or our steps we're going to use is we're going to sketch on the coordinate plane our angle. We're going to then determine if the ratio is positive or negative using what we learned in the previous section. And then we're going to use a reference angle to draw special right triangles and then find our ratio. So we're going to kind of go back to thinking about our special right triangles. We know we have the 30, 60, 90 triangle. We're going to use this ratio, our 2, 1, root 3. And then we also have our 45, 45, 90 triangle. The 1, 1, radical 2. So we're going to do that without having the variable in there. We're just going to be using those coefficients to solve. First example, we're going to be evaluating sine of 210 degrees. So our first step is we're going to just simply sketch the angle on the coordinate plane. So if we remember how to sketch that, we're going to find that 210 degrees is actually going to fall in quadrant 3. All right, so that's our first step, is just to simply sketch the angle. We're now going to go ahead and I'm going to now make a reference angle so I can go ahead and do some calculations. So I'm going to find what my reference angle is right here. And if I was, and I know this again is 210 degrees, if I do 210 minus 180, I'm going to get 30 degrees. So my reference angle here is actually going to be 30 degrees. We're now going to go ahead and hopefully we recognize that this is a special right triangle. So we're going to fill in our ratios. Our hypotenuse is 2. The ratio next to the 30-degree angle is root 3. And then this was our 60, and this would be a 1. If I'm going to then determine what sign we're going to be using here. So I'm finding, the function I'm finding is actually sine. But am I using a positive or negative value? So if I think about all positive, sine positive, tangent positive, cosine, we actually know that in this one, tangent is positive. So that means sine is actually negative, right? Because the only one you could have more than one positive is the quadrant 1. And then I can see sine is opposite over hypotenuse, which is 1/2. So my answer would be the sine of 210 degrees is a negative 1/2. Is done in a very similar way. So if I sketch 300 degrees, I'm going to be in quadrant 4. I'm then going to drop a reference angle. So I'm going to do 360 minus 300. I'm going to get a 60-degree angle. And hopefully, again, we recognize that that's a special right triangle. So I'm going to go ahead and label this out. So this would be my 1. My hypotenuse is 2. This would be radical 3. In quadrant 4, only cosine is positive, right? So tangent is actually going to be negative in this quadrant. So I'm going to write tangent of 300. I know it's going to be a negative value. And tangent is opposite over adjacent. So negative root 3 over 1 or negative root 3. And that would be my final answer. For the next one, I'm looking for cosecant. Cosecant is, remember, that's just the reciprocal of sine. So really, it's like I'm thinking about the positive and negative properties for sine when we're doing this problem. So 135, if I sketch it, it's actually going to be in quadrant number 2. If I calculate my reference angle, I'm going to do 180 minus 135. We get 45 degrees. Again, we should hopefully recognize that's a special right triangle. And I would have 1, 1, and radical 2. If I think of my sines, I'm going to have all Slurpees taste cold. Sine is actually positive in this quadrant. So my cosecant is also going to be positive. So I'm going to put a little positive so I remember. And sine is opposite over hypotenuse. So cosecant is the reciprocal, so that'd be root 2 over 1, or just simply root 2. And that would be my answer. First example, we're given a couple different pieces here. We're given that the tangent of the theta is less than 0, and also cosine is 1/2. So if we fill in everything we know cosine is 1/2. That means secant is 2 over 1, which is 2. Tangent being less than 0 means that it's negative, so that also means cotangent's negative. And what we have is then an angle that's in a quadrant where cosine is positive but tangent is negative. So the only place that could really exist is in quadrant number 4. And if we fill in what we know, if cosine's 1/2, the adjacent's 2, the hypotenuse is, the adjacent's 1, the hypotenuse is 2. If I was to do Pythagorean theorem, but hopefully we kind of recognize that actually it's going to be a special right triangle. But just so you can see, we actually are going to get radical 3. And now we can actually fill in the rest of our ratios. So sine would be radical 3 over 2. And in this case, we actually know it's going to be negative because only cosine's positive in this quadrant. Cosecant would be the flip of that. So negative 2 root 3 over 3. And then tangent, we can see is going to be root 3 over 1. Which is negative because tangent's less than 0. And then if we do the reciprocal, we get negative root 3 over 3. So we know our only positive one is going to be cosine. And then if I wanted to find the angle, hopefully we recognize this is a 30, 60, 90 triangle. And so if I do 360 minus 60, this is a 300-degree angle. This next one, we're going to, given that we have a ratio and a restriction, we're going to want to know the quadrant. We'll do our 6 ratios, and then we can also figure out what the angle actually is if we needed to. So if we fill in what we know that sine is root 2 over 2. And we also know what cosecant is. That's the reciprocal. So we know that's going to be 2 over root 2. And if we rationalize that out, we're just going to get radical 2. We're also told cosine is less than 0, so that means it's a negative. And since we have opposite signs for 2 of the ratios, I know that the third ratio actually has to be negative, right? Because the only quadrant where you could have more than one positive is quadrant 1, and then all 3 of them would have to be positive. So when we go ahead, if we were to sketch this out, so if we think about all positive sine, tangent, and cosine, we only have sine positive, so that tells us it has to be in quadrant number 2. If I was to write this out, this would be root 2, 2. And then if I was to do Pythagorean theorem, to find this if we needed to, you might also just recognize that this is going to end up being a special right triangle. But if I was to solve it out, you can see we'd get radical 2 again. And you can see it's actually a 45, 45, 90 triangle. When we solve this out, we get something very similar. Tangent would be root 2 over root 2, which is 1, and same with cotangent. And if this is 45 degrees, and this was my original angle, I can do 180 minus 45, and we would get 135. So that angle is actually 135 degrees. So we kind of used all of our pieces together to recognize what special right triangle that was, and then subtracted to find the original angle. If you have any questions, please make sure you ask them during T-Bowl time, during class, or you can come to the center. And remember, you do need to complete the You Try problems to receive full points for the notes.